Hey guys, so we're going to be doing today volume, and we're going to be talking about three-dimensional shapes, which I'm super excited about. So the first thing that we're going to talk about is finding the volume of a cylinder. Please make sure that you are following along in your workbook and you're on page 590. Volume of a cylinder. And so we're talking about like soda cans, right? How much soda can you get in there? How much Monster can you put into a soda can or whatever? By the way, you should never drink those things, but whatever. Okay, so let's talk volume. There's a couple of things that I want to make sure that we talk about. One of them being your handy dandy calculators. Okay, so I definitely want to talk to you about those. As well as talk to you about volume. Okay, so first thing that you need to know is the volume formula. The volume formula is big capital B and then H. The big capital B stands for the area of the base. And since the base of a cylinder is a circle, then we need to do pi r squared. And then volume gives us the third dimension, right? 3D shapes, that third dimension is going to be the height, so how tall it is. And so this is the formula for finding volume of a cylinder. Let's go look at example number 1. I want to talk to you about your calculators. There's something that we need to talk about as far as using calculators and that sort of thing. Now, I don't care if you're using the one online, you can use Desmos, you can use any other calculator that you want, but you definitely want a pi button, okay? And so that's what I want to talk to you about really quick. So volume formula, here it is, pi r squared h, right? So we're going to do pi times, remember r is the radius, and so that's going to go from the center out, so 5 squared, and then times 8.3. Now, you're probably thinking, listen, Hunsicker, it says right there on the page what I'm going to type in. I don't see what the problem is. But again, let me show you what I'm talking about, okay? If we just do 3.14, which is pi, right? And I do times, let's see, what am I doing again? 5 squared, right? Which is 25 times 8.3. I'm going to get a different answer, look at that, than what they got. Their answer is 651.88. I got 651.55. You want to make sure that you are using the pi button, okay? Pi is 3.14159261626159. I don't know. I don't remember all of them. My daughter's really good at them, me not so much. But it's all of these decimals, and it's a number that goes on forever, right? So you want to make sure that you use the actual pi button. On my calculator, it's up here. It's in blue. I would have to hit the blue button. So I would do pi times 25 times 8.3, and I'm going to get a much better, much more accurate answer, okay? And that's what we're looking for. So your decimal points are really going to matter this time. Okay, so if you take a look at example number 2, example number 2 says there's a diameter of 16 inches. So this is the other thing you have to be careful with. A diameter goes all the way across, and the formula says pi r squared, and so you're going to have to cut that in 2. So the radius is only 8. So that's why they use an 8 squared. Okay, and then the height, of course, was 20. So here's our cylinder. All right, let's go take a look at the got it problem at the bottom of the page and see how well we can get it. Got it? All right, here we go. So we're going to do pi times r, which is 3. So I'm going to do 3 squared, and then times 1.8. And again, I want to use the pi button on my calculator. So here we go. Pi times 9 times 1.8. is about, and it says round to the nearest tenth, so I'm going to do 50.9. That is my answer to part A. If I only use 3.14 times 9 times 1.8, I'm going to get, oh, look at that. I did end up getting the same thing, so good job. However, that might not always happen, so you have to be really careful, okay? All right, letter B says diameter is 12. Well, if the diameter is 12, what's the radius? The radius is going to be 6. So we've got to make sure we get the radius, okay? So we're going to do 3.14. I'm sorry, we're not doing 3.14. Hunsaker, really? Seriously? Okay, we're going to do pi times 6 squared times 5. So here we go. Pi times 6 squared times 5, and we get 565.5 if I round to the nearest tenth. Okay? All right, let's go take a look at example number 3. So example number 3, up at the top, we have a metal paperweight in the shape of a cylinder. Paperweight has a height of 1.5, a diameter of 2. And so how much does it weigh? Oh, and there's an extra little caveat. How much does it weigh if 1 cubic inch weighs 1.8 ounces? And so you just have to figure out what the volume of the cylinder is. Okay, so it's a metal cylinder. Okay, the volume is going to be 4.7 cubic inches, and it says that 1 cubic inches weighs 1.8 ounces, and this has 4.7 cubic inches, so you're just going to multiply it, and this is how much it weighs. It weighs about 8.5 ounces. Okay, so that's a good size for a paperweight. All right, let's go try this problem down here, letter C, the Roberts family. So the Roberts family is going to be recycling aluminum cans. Here's those soda cans that we were talking about earlier. It says that there's a container shaped like a cylinder to recycle them, right? The height is 4 feet. Let's draw a picture. So the height is 4 feet. And the diameter, so we're already thinking, oh, we're going to need a radius, okay? The diameter is 1.5. So let's go take 1.5 and divide by 2. So I know that my radius is 0.75 feet, okay? And it says the container is full. So how much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot, okay? So let's go see. Here's our cylinder. Let's go get the volume. So we're going to do pi times 0.75 times 4. I need to do my radius squared, so it's pi r squared h. So let's go type that in. Pi times 0.75. Now, you have some choices. If you don't have a squared button or you're using a calculator like on your phone and you don't have the scientific calculator or whatever, you can just type in 0.75 twice if you want. That's fine too, okay? Times 4, and so this is 7.1 cubic feet, okay? And it says the container is full. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic feet? So we're going to take 7.1 and we're going to multiply by 37. Now, it's really important. I know you're doing a lot of things in your calculator right now, but it's really important that you write down what you're typing into the calculator. That way I can see what you're doing. I can help you out if there are any mistakes that you happen to make, okay? So make sure that you write your work down, right? You know how it works, right? No work means no credit. Okay, so again, make sure you're showing me what you're typing in. All right, let's go take a look at the next part. Volume of a composite solid. What is that about? Composite solid. Well, composite solid just means that there's more than one. Okay, well, there's more than one. So let's take a look at this particular problem. Tanya has a cube-shaped bead. So here's a cube-shaped bead. By the way, do you know how to find the volume of a cube? Remember, it's length times width times height, right? Okay, so we have this cube-shaped bead, and it says there's a circular hole through the middle. And so there's like this hole. That's where you can put the wire, and then you can put the beads together and make like a bracelet or a necklace, okay? So we want to find the volume of the solid. So we're going to find the volume of the box, and then we're going to take this little cylinder shape right here, and we're going to cut it out. Okay, and that means that we're going to have to subtract it at the end. So we're going to do length times width times height, 12, 12, and 12, and get 1728. We're going to find the volume of that cylinder. And so pi, I wonder why they used a 1 right there. Why'd they use a 1 right there? Oh, because the diameter was 2, so you had to cut that in half. So we do 1 squared times 12, get 37. And then here's the box, and we're subtracting the cylinder, so our final answer is 1690.3. Okay, let's go try one of those. So flip the page. Let's go do the got it at the top. Okay. All right. So it looks like we're building storage chests. I was going to say that kind of looked like a mailbox. But we're going to donate this to charity, and I want to know what is the volume of this box. Okay. So, or this chest, I should say. So the first thing we're going to do is find the volume of this rectangular piece at the bottom. So let's go find the volume of the bottom. So we're going to find the volume of the box. Volume of the rectangular prism, right? The box is going to be length times width times height. So we're just going to do 30 times 25 times 50. Let's get our handy dandy calculator. 30, 25, and 50. And we get 37,500 cubic centimeters. Okay. And now let's go find the volume of the top. So this is not quite a full cylinder. This is only half of a cylinder, right? It's like a can or whatever, a cylinder, but it's been sliced down the center. Okay. If this side right here is 25, well, this side right here is 25, but that is a diameter and we need a radius. So we're going to go take our diameter and divide by 2. So my radius is going to be 12.5. How tall is this cylinder? If this cylinder was standing up and I could twist this, it would be 50 centimeters tall. And so we're going to use that with our formula. So the volume of the cylinder, and by the way, we're going to do the volume of the whole cylinder. It's going to be pi r squared. So we're going to do 12.5 squared times 50. Okay, so here we go. Pi times 12.5 squared times 50. And we get this big old honkin' number. But what do we have to do with that big old honkin' number? It was only half of the cylinder. So we're going to take that number and we're going to divide by 2. And so when we take this and divide by 2, we end up with 12,271.8. And then what am I going to do with these two numbers? Yeah, I'm hoping that you said add, right? So we're definitely going to be adding them. So 37,500 plus 12,271.8. Let's add 37500, and we get 49,771.8. Okay. All right, let's go put in our dimensions. We're looking at cubic centimeters, and we're good. Look at all this work that I wrote down. So one more time, no work means no credit. Make sure you show me what's in your calculator, what you're typing in, okay? All right, now would be a really good time for you to pause your screen, go in and try the guided practice problems, and then come back to me and you can check your answers. Let's go do that. Let me get us paused. I can remember how to do that. All right, guys, so we got that. I want to double check a couple of answers with you, and I wanted to talk to you about a couple of things. So hopefully you got a 56.5 on the first one. Looks like this should be cubic centimeters, Ms. Hunsicker. On the second one, remember you need pi r squared. You need a radius, so make sure you cut your diameter in half. And then the other thing I wanted to show you, look, we finally got a different answer. And so if you use 3.14, you're going to get a 401.9 instead of a 402. And by the way, that is not correct. So make sure, okay, you want a more accurate answer that you use that pi button, okay? Number 3, I know says that it is a sculpture for an art project, but it totally looks to me like the cat thing that we have at the house that my cat climbs on. And so I drew a picture of the cat. But if we needed to find the volume of it, remember there are 2 boxes. So I did the length times width times height times 2, because there are 2 of them, and got 1600. Here's the volume of my cylinder, which I had to round to 754 because this 8 would make this 9 go up, which would make the 3 go up to 4. And when I added together, I got 2354. Number 4, this was the scented candles. And so imagine if you're a candle factory, right? And you need to figure out how much of these candles going to weigh, how much mass is in them. You're going to have to be able to do this math, okay? And so here's our pi r squared h. And then we multiply by the 3.5, okay? All right, so I hope you got all of those correct. I'm feeling pretty good about it. Here is your assignment. You're going to do page 593. Okay, so your homework is page 593. I'm going to give you a bonus question today. Your bonus question is actually number 7 on the next page. Okay, so this is bonus. This is extra credit. Make sure you show all of your work. Okay, we have 2 equally sized sheets of construction paper. We're just going to call this a regular old sheet of paper. And so it's an 8.5 by 11. So I want you to use those dimensions. Okay, 8.5 by 11, and see what you get. Again, this one is bonus. Your other assignment is to do all of page 595. Okay, and so remember, you're going to submit a picture or something. So 593, 595, and then number 7 is going to be bonus. Okay, all right, happy voluming.